Okay, for this video, some of this information you can get out of section 3. Some of it is just basic knowledge about the atom that you probably already know. So I'm going to do the first one for you. On sodium, number of protons, so we just look on the periodic table. Its atomic number is 11, so that tells us we have 11 protons. Since this is a neutral atom and it doesn't have a charge, it's going to have the exact same number of electrons, so we can also put 11 here. For the column for ending electron configuration, this would be what you would put down for the noble gas electron configuration. So let's see, sodium's number 11. We go to our noble gases. The noble gas that comes before is neon. So put neon in brackets. And then we put 3s1. If we total up our exponents in a noble gas electron configuration, it tells us the number of valence electrons. So for sodium 3s1, we only have one valence electron. Another thing we can do to get valence electron is to look at the periodic table. Everything in group 1 has one valence electron. Group 2 has 2 valence electrons. We skip over to group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and group 18 has 8 valence electrons. All right, you can add those numbers to your periodic table if you want to. Group number, very first column. So this is group number 1. All right, so that was fairly easy. Now in the ion section, so ions are atoms that have gained or lost electrons. Well, we have to determine which one did it do. Did it gain electrons or did it lose electrons? So all atoms want 8 valence electrons. Sodium only has 1. Atoms are very lazy. They want to do whatever takes the least amount of energy. So we have to decide, is sodium going to try to give this 1 electron away, or is it going to try to gain 7 more? If it gives this 1 electron away, then it's going to be similar to neon. If it gives away 1 electron, it'll have 10. So neon has 8 valence electrons in its outer shell. So if sodium gives away an electron, it'll have 8 valence electrons in the second level. Losing 1 electron takes a lot less energy than trying to gain 7. So in the column where it says to become stable, we're going to put lose 1 electron. If we lose an electron, it doesn't change our number of protons, so that's still 11. If we lost an electron, we now have 10. And then it says ion charge. Well, if we have the same number of protons and electrons in an atom, and we lose 1 electron, we now have 1 extra proton. So that would be our charge. It's a +1. So we have 1 more proton than we have electron. So now looking at the periodic table, sodium, everything in this column has 1 valence electron. They're all going to give that 1 valence electron away. So they're all going to have a +1 charge. In group 2, these all have 2 valence electrons, and it's easier to give away 2 than to try to gain 7. So these all have a +2 charge. We skip 3 through 12 because their number of valence electrons can vary. And we go to group 13. Group 13 has 3 valence electrons, and it's easier to give those 3 away. So it has a +3 charge. The carbon group can go either way. It takes the same amount of energy to gain 4 as it does to lose 4. So we put ± 4. Nitrogen is where we switch. So now we have 5 valence electrons. So it's easier to gain 3 more than it is to give away 5. So if we gain 3 electrons, we're gaining negatives. So these have a -3 charge. Oxygen has 6 valence electrons, so it's easier to gain 2. It's -2. And fluorine has 7 valence electrons. It's easier to gain 1. So that becomes -1. And the noble gases, they already have 8 valence electrons, so their charge is 0.